Welcome to this instructional video aimed at people who wish to use the UKIE country kit with Civil 3D 2025. My name is Joe Wright and I've been responsible for the UKIE kit since 2019. This video will be showcasing the new improvements to the country kit, but I shall also be following a workflow storyline rather than just knocking out new feature after new feature. That way I hope I can include some stuff that will appeal to all ability levels. So for the diehards, you will get to see everything that's new, and for a complete beginner, I hope you find enough encouragement to open the box and look inside. Now, this video is nearly an hour long, and I completely get that maybe you don't want to sit through topics you have already mastered or that are irrelevant to your work. To this end, and after the brief overview that follows, I'll indicate where to skip to in the timeline for those who are purely interested in the new pipe network stuff and or the new rail improvements. Okay, let's start at the very beginning. What is the UKIE country kit? Well, simply put, it's a collection of stuff that complements Civil 3D, specifically aimed at the designers in the British Isles. Historically, UKIE was one of the very first country kits released and distributed by Autodesk. It has been improved year on year. In a nutshell, it incorporates many of the standards from various civil-based disciplines, as well as ensuring you have working defaults to enable you to hit the ground running without spending ages building up the basics. Now, I realise those slides zip past really quickly, but if you want to know more about the basics, take a look at some of the other videos in this series. They can be accessed by Googling the @Autodesk UKIE YouTube channel, or simply by clicking the buttons on the UKIE tool palette once you've downloaded and installed the product. But for now, we've got bigger fish to fry. Some of you may already be using UKIE 2025, and the first version for Civil 3D 2025 was released in September. This was later than usual, as I usually like to deliver in May or June, shortly after base product is available. However, we had a lot to do. All the underlying code in UKIE has been upgraded to .NET 8. This means it works faster, has a lower size profile, and can simply coexist with Microsoft Windows a lot better. We see this as future-proofing, and it ensures UKIE has many country miles ahead of it. Also, I took the liberty to clean everything up, all the reference files and unneeded items, and I also rolled my sleeves up and addressed as many of the little minor outstanding bugs that I could find. The one change you may have already noticed for this release is that it's now downloadable only from the Autodesk Subscription Centre, and I will start by showing you how to do this. But this early version of UKIE, released in September, didn't contain much new. All the hard work had been in the background tasks like updating .NET 8. But there is now a new release, UKIE 2025.1, and this was released in December. It contains the new, nice stuff. Basically, we did the things we needed to do first. Now we've done the stuff we wanted to do. The big thing here is a brand new network catalogue for pipes and manholes supporting the design and construction guidance document for adoptable sewers. The full name of the standard is on screen, but I will refer to it as just design and construction guidance from this point forward, otherwise I'll get my knickers in a twist. Also new is a support for network rail based turnouts, specifically NR60 Mark II. This ensures correct geometry is delivered to P-way designers as per the network rail specifications, specifically focusing on the diverted alignment. And I have, of course, updated the documentation so that anyone can look at the detail of what's been done on these 2 new editions. Now, if you know all about the basics of pipe networks, you may wish to skip to approximately the 29-minute mark. This is where we will showcase the new pipe network catalogue. And if you're just here to see the rail improvements, well, roll forward to just before the 47-minute spot. And so, without further ado, let's jump down the rabbit hole. Okay, so first up, as I promised, how to download UKIE for Civil 3D 2025. You need to visit your Autodesk subscription portal, manage.autodesk.com, then sign in. Go to all your products and services and find the Civil 3D section. After all, UKIE needs Civil 3D. No point downloading it unless you've already installed the base product, i.e. Civil 3D 2025. So make sure you've already installed that. Then you can click on View Details here. Then make sure you're on the 2025 tab at the top. Now, you're not out of the woods yet because it's not listed under Updates. It's actually listed under Libraries. So click here. The one I'm downloading is actually the September version. The only reason the September one is shown is because it's currently November and the new version hasn't been published yet. But you will see a December variant, and this is a great reason to subscribe to this YouTube channel, as any new videos I post may just give you a little heads up. Anyway, back to the task at hand. Click Download, save it to a file location, run it, and follow the installation process through to completion. Okay, things may change on this subscription portal, so if you've chanced across this video a few years into the future, you might have to hunt around a little, but country downloads from 2025 onwards are now linked to your subscription benefits. Once the UKIE 2025 library has been installed, you will have a new icon, Civil 3D 2025 UKIE. This is what you need to click to ensure you boot up Civil 3D with the country kit. Ignore the other Civil 3D shortcuts if you have them. How do you know it's running? Well, firstly, clicking the tool palette icon up here will bring up the UKIE stuff. And look, here are some of the other videos I mentioned earlier. And here's the full documentation. There's quite a lot of it, but it's quite a nice little bedtime read, I think. Okay, we've got the right environment, so we're good to go. First thing to notice is look at the coordinates. Yep, those big numbers mean we are geolocated. Notice also the geolocation tab up at the top. This will be available whenever you need it. I'm going to click on Maps because alongside Bing Data and new in Civil 3D 2025, you can see alternative map providers. In this case, Esri Data. Now, some data is better from one provider in certain spots and another provider may look better in a different spot, if that makes sense. But hey, it's easy to play around with whenever you need it. The area we're going to look at is actually my hometown of Shipley. Shockingly, the town is landlocked and nowhere near the sea despite its name. And we're going to be looking at this site here, which was developed just before the pandemic. To get a story going, I'd like to look at this, how it used to be. And we're seeing live mapping data currently on screen. But if you do have older aerial images, or even higher resolution ones, I can use the Map 3D tools, which are included with Civil 3D. To use the Map 3D tools, click the icon at the bottom of the screen and choose Planning and Analysis. Look, everything changes. The ribbon is different, and this thing appears at the side. This is the map task pane. It will come in useful shortly. But for now I'm going to go to the Insert tab and choose Insert Image. Or you could type Map I Insert on the command line if you can't be bothered changing to this planning and analysis workspace. Anyway, I'm going to pick aerial photography from 2016 and it will drop perfectly in position. You can see it overlaid on top of the big map. I can then add this to the thing at the side so it becomes a selectable key. Click Data and then Drawing Data, then Raster Image. Tick it and it can be turned on and off without going through the rigmarole of freezing the layer or hiding the object. We can also use this data icon here to attach to lots of data sources. Look at the list. And I don't know about you, but the UK Government Environment Agency website is full of free data we can download. I tend to grab quite a lot of data from there, so let's attach a .shp file of some flood analysis data I downloaded a couple of weeks back. Here we go, it's now referenced. All I need to do now is click Add to Map to overlay it into my drawing. It is then turnable on and offable, like the raster image, and I can even change the styling. And there's a lot more you can do here, but in this case I will just add a little transparency. Easy peasy. Right, I'm going to quickly, by speeding up the video, add some other aerial photography that I have from various other dates. This one from 2018 shows the site after the groundworks have been completed, and this one is a high-res image taken recently. We can also change the draw order by dragging the items up and down the list at the side. So I now have full control of what I see on screen. Let's just show the groundwork aerial photo. You can see some of the flood defences that have been added to mitigate the effect of the flood data we displayed. Let's pop back to Civil 3D. To do this, simply go back to that cog item again and select Civil 3D, and we're back where we started. Now, if you want to see that task pane in this environment, just type Map W space at the command line. I have it on my other screen. I don't want it to get in the way, and you may notice I turn stuff on and off with it as we progress through this project. So, back to the plan, Stan. This site is already modelled in another drawing. We are going to use data shortcuts to grab aspects of this model. It's a little bit like attaching an XREF in AutoCAD or even overlaying the .shp file you saw a couple of minutes back. Data shortcuts allow you to reference multiple individual Civil 3D objects that are in other drawings. I'm not going to go into too much detail, but I will be demonstrating the day-to-day basics of working with data shortcuts. After all, using data shortcuts is good practice. If you want to know more detail about this topic, look online. There are plenty of tutorials. Now, if you look at my published data shortcut objects here, you can see I have a number of surfaces available. Let's choose the one that on the surface of it matches the aerial photo. Look, we have surface after groundworks. Right click and create reference, and then you just need to choose how to display it. In this case I'll pick tight contours. As this is a referenced object, it doesn't actually exist in this drawing. I can, however, open a drawing where it does exist by simply right-clicking and choosing Open Source Drawing. Here we go. Now don't be intimidated by this drawing. It's just the completed road and junction design. The main thing to point out is that this drawing has a number of surfaces up here, generated at each step of the project. This is the one that we referenced earlier. But this drawing also contains a road corridor made up of a few junctions and some other surfaces. Let's take a peek. If I select this display surface along with the corridor and look at these in isolation using Object Viewer, you can see the terrain. But I have draped the 2018 aerial photo over it, so if you shade this in realistic mode, you get a great image to show the stakeholder. Nice. But let's return to our other drawing, and I will delete the groundwork surface previously added and reference in the final ground surface. That's the surface after the top of the road has been added, and I'll style it accordingly. We are now going to focus on pipe networks, and specifically the new catalogues included with UKIE for design and construction guidance. Look at the prospector over here, and you can see we have no pipe networks in this drawing. I do, however, have an existing one that I can reference in through the data shortcuts. Here it is. Let me add it to the drawing. Whilst this is a foul sewer network, I will change its styling to something that stands out so we can differentiate between a new and existing one. Here we go. It's in. You can just about make out the red dots, obscured by all the contours. Let's restyle the surface so they don't get in the way. This is a 3D pipe network, even though you can currently only see the schematic. Watch. If I select one of the manholes and choose Object Viewer, voila, it's in 3D. As a matter of fact, you can look at the entire network in 3D by either windowing or choosing it from the browser at the side. Let's try it. Now, this was a network I made earlier, but if you truly want to start from scratch, you will need to build up a parts list. You can do this by expanding the Modify tab and choosing Create Network Parts List. Then you can start adding the pipes and the manholes that you want in your list. And for those of you who are already familiar with this, you can see all the older ones from previous releases are still available, but you will also find a new section for design and construction guidance. This list matches the structures found in the specification document. Notice that the index inside the brackets refers to the figure number from the Design and Construction Guidance Manual. This makes it easy to cross-reference and produce a schedule. But we don't necessarily need to create a new parts list. The UKIE template has 3 pre-populated parts lists. As you can see on the Settings tab, and these are for combined, foul and surface water, and each contain a fair selection of manholes pertaining to the guide. Also, there's a good selection of pipes, including some new twin wall ones. So we can just crack on and use one of these pre-prepared parts lists. Before building our new network, let's restyle the surface with fewer contours than before, just so I can visually reference the relief on the surface and identify one of the cul-de-sacs, which I hope is about here. Yep, that's right. So let's start. I'm going to draw a foul network, purposefully using some inappropriately sized manholes, just to give an introduction to best practices working with pipes and structures. Don't forget to select the surface at this stage, or you will not get any cover levels. Press OK and you have an empty network. But you could choose a manhole, and like I said, I'm going to use one of these big guys. Now these are normally 3 meters to 6 meters deep, and I'll choose a 375mm concrete pipe. I'm going to put one here, one there, and one in the middle of the cul-de-sac road. Done for now. I've kept it simple to highlight the underlying mechanisms at play. I'll quickly switch the contours off, then select the new objects and we'll look at them in 3D. Now, if you are a pipe network designer, you'll probably spot quite quickly that this just looks wrong. The reason being is that the pipes are not at the bottom of the manhole. And you might think this is something to do with a sump setting somewhere. But I did choose those very deep manholes to demonstrate this point. Now this may be better shown in profile. And getting a profile is simple. Just choose Draw an Alignment from Network Parts up here. And then select the first manhole in the run. Then the final manhole in the run. Couple of things to look out for here. Firstly, be sure to have the box ticked to create the profile before continuing. And then, secondly, it's worth profiling along with the ground surface so you can visualise the cover level. Just click Add against your declared surface. Then do not press that OK button. No, don't do it. Press Draw in Profile View. Finally, I would change the Profile View style to Natural Scale before pressing Create Profile View. Otherwise, everything will appear 5 times deeper. Oh, and don't worry about all this other stuff for now. Just press Create Profile View and then simply pick a point where you want to drop it on screen and let's see what we get. Okay, so this profile also confirms our issue with the pipes being too high. But before we look into this, let's tidy things up a bit. For example, look at this first manhole. It's hidden under the labels. That's an easy fix. Just click the profile view in the drawing window. Any of the white lines will do. And then pick Profile View Properties on the ribbon. This is where you can change all those options, most of which we skipped about 20 seconds ago. Look, here is that profile view setting that we changed to natural scale. And to be fair, this was the only thing we changed. To get the manhole away from the axis is easy. Just make the chainage range larger. I'll start it at -2 and add a couple more meters on the end. Done. Perfect. Now, whilst very important, I'm actually going to delete the band sets at the bottom of this profile, just to give us a better visual experience. Now, you shouldn't do this. Band sets are very useful and you can display lots of information on them. Indeed, a lot more than you saw originally. Now, I'll split the screen so we can see the plan and the profile concurrently. You might notice that this first manhole is actually orientated differently to the other two. To see why, let's examine the structure properties via a quick right click. Notice the style is set to DCG for manhole. We can change this to DCG geometry display, and you can see that in both views the full geometry of the item is now displayed. We can then use the grips in plan to rotate this item to match the others. Notice that this follows through in profile. Let's go back and look at that Part Properties tab again. This has all the variables you can alter, such as cone height and the diameter of the barrel and the wall thickness. These are all changeable, as you can see. I'll set the style back to as it was. While showing full geometry can be useful, the basic style matches the specification and it certainly looks a lot tidier in plan and profile. I am going to place a quick undo mark at this stage because I aim to get back to this point later. So back to those pesky pipes and the reason why they are not at the bottom of the structure. Well, the reason is simple. The manhole we inserted, according to the design and construction manual, is a minimum of 3 metres deep. The pipes, on the other hand, have a minimum cover level of only 1.2 metres, and it's worked out that the pipes can be installed higher up without breaking the minimum cover level along the length of the network. So basically it's telling you that you don't need to put in such deep manholes based on your current network design. We can easily change this pipe cover manually if needed by looking at the part properties of the pipe. Look, we can change the slope, but we can also change the start and end soffit levels manually. We can just put in a new value if we must. You can also do this by dragging the grips on the screen if you wish. But that's not the point. We really want this to just match the manhole specifications and get the software to do the work for us. Now all the pipe networks behave according to the rules assigned to them. By default, pipes are inserted on the generic rule shown here with an optimal cover level of 1.2 metres, which actually visually works quite well on the majority of manholes. But to link the pipe to the manhole specification, you just need to change its rule set. These are type A manholes, so we just need to change the pipes to the matching rule. And look, it's already figured out the pipe is not covered enough. Now all we need to do is apply that rule. To apply the rule, click the pipe and choose Apply Rule on the Extended tab. Now that's sorted out the pipe, but the manhole adjusted incorrectly. And guess what? The manhole has rules too. Applying them will sort things out. Now when applying an individual component, I often find it better to right click to apply a single rule. But this one at a time mechanism can be painful, especially if you have 30 pipes in your network. And that's why I put an undo mark in earlier. So let's go back and see how we can do this wholesale. Now remember, we only have 2 pipes and 3 manholes here, but think of the bigger picture because the method I'm about to show you saves more time the more parts you have. Righto, click any of the parts and on the ribbon select Edit Pipe Network. Click the Panorama Table button here and you'll see a list of all the manholes. Let's say we wanted to change the style of them all so we see that 3D geometry we saw earlier. Just right click the Style column and choose a new style. Wholesale. It'll change them all. There is also a Pipes tab. So let's right click the Rule Set column, choose Edit and change the rule. Wholesale, it changes them all. All rules are now set as needed, but we still need to apply them. We want to apply the rules to the whole of the run. And the trick here is to select 2 components, not 1, 2 components from the plan view of the network. Then choose Apply Rules from the ribbon bar. It will then ask to select the upstream part and the downstream part to determine the length of the run you wish to apply the rules to. And here we go. But it's not done the first one, but that's easily fixed. I'll list on the screen now the new additions for the Design and Construction Guidance catalogue. Most of the 12 new rule sets have been based on foul networks, and they are not adjusted to cater for differing flow volumes. But these can be considered a good starting point from which to copy and alter to follow any specific requirements. Notice also the addition of new outfall structures. So I think it's time we took a good look at building a storm network and experiment with some of the new manhole and pipe types, including those fancy new outfall structures. To help with my design of this new storm network, I'll reference the alignment that represents the crown of the main estate road. This is available in my data shortcuts, originating from the model you saw earlier. I'll use the chainages on this alignment to position my manholes. Okay, let's begin. And I'll create a new network based on the DCG Storm Network parts list. And as before, don't forget to declare the linked surface or you'll be lost. We shall start off with a Type D rigid manhole that can take a little bit of a vehicle load. Now let's just pause for a second and look at the design and construction guidance document. Type D B39, that's this one here. See how each catalogue structure references the item in the document by its figure number. Happy days. Okay, onwards. We'll use the new twin wall pipes just so that everything we draw is a new part introduced for UKIE 2025. Now, I will draw this referencing the alignment, and to do this I'll use one of the most useful transparent commands. That's this one, chainage offset, or station offset if you're not running the British variant of Civil. And it does what it says on the tin. It will find a point along the alignment at the declared chainage at a specified offset from it. So I know the cul-de-sac junction is at 178 metre chainage point, and I want the manhole 15 metres away. It's that easy. It also allows you to enter the values on the ribbon, but I'm happy entering them on screen. The next one I'll place at the centre of the junction, same chainage, just offset by 0 metres. I'll now change the manhole to a flexible variant with a pre-cast concrete slab on top that is suitable for installing in the sub-base of the estate road. Again, let's pause for a second and look at the manual. I'm sure you'll agree the link is obvious. Now, I'll continue adding along the alignment at set chainages. That one here, and we'll put one there. Now I'm going to go across the field and place an outfall into the beck. As I don't have any survey information to hand, for this I will need to see the contours to help me place the outfall. So a quick surface style change is needed. Notice I didn't need to close down the build bar, it's a floater. We'll make it a thicker pipe. And as you can see, I'm able to restart drawing once again by connecting to the glyphs that appear over the existing parts. I'll put an intermediate structure in the middle of the field, and I'll up the pipe size once again, and then select a suitable outfall. And as this pipe is over 350mm, I'll need one that has a safety grill. And I'll place it roughly in the bank of the beck. Done. Let's look at this in 3D. Now everything was built using a generic rule set, but this was good enough for my purposes of highlighting the new stuff. Look, you can see the outfall at the end, and looking through it, I'm sort of not happy with the one in the middle of the junction. I might swap that out later. And as we did before, I'll create a new alignment to cover the run and create a profile. Don't forget to add the ground surface you need to reference for cover level. And before drawing in the profile view, I'll change the scale to natural. Again, I'll tidy up to get rid of the data bands for visualization purposes. Don't do this at home, folks. Now, to tidy up the endpoints of the profile so they don't interfere with the geometry, I will use a different method. This involves extending the newly created alignment, and you'll need to switch on the object snap called extension. There it is. Now this bit takes a a lot of practice, but you can select the start of the alignment and extend it to set distance prior to the first structure. And we'll do the same at the other end. Oops, try again. Like I said, it needs a bit of practice, but the big benefit here is that you can see the existing ground before and after the first and last structures. And this is going to help us in placing the outfall correctly. Okie dokie. Oh, I wanted to change that second manhole. Let's do it before I forget. It's simple. Click, swap part, choose a new one. Done. Now, let's focus on that outfall. It needs positioning better, and the rules assigned to the pipe have pushed it underground due to the cover level rule. But of course, an outfall by its very nature really needs to ignore the minimum cover rule. Sure, we can move the outfall up in profile and along in plan, but applying the rules will always force it back onto the end of the pipe. The solution is to change the pipe in profile, and the outfall will follow. Once in place, we can always examine the rule for the connecting pipe to check that the slope is okay. In this case, we do need to lower the gradient, and our rule claims the maximum is 2.5%. So we maybe should manually adjust this on the part properties sheet. Let's take a look at this in 3D. Very handsome beast, albeit with a very basic effigy of a safety grille. Let's see how this model works and change the style so we can see the geometry in plan and profile as we did earlier. The part property sheet shows a host of variables. Structure length changes this dimension. Structure height effectively changes the depth of the base, and the structure width changes the outfall spread. But look at the connecting pipe. It doesn't seem to fit very well. Let's check it out in 3D. Ooh, that's no good. It can be changed, and the variable needs to match the outside diameter of the connecting pipe. So let's measure it. 518mm. Now, in designing the model, and to get this working accurately, I had to hijack a variable, namely vertical pipe clearance. Here it is. It just needs to match the 518mm measurement. The default for this outfall is 919mm, so for an absolutely spot on 3D model, it will need to be changed to match that of the connecting pipe. Done. As you can see, it's now spot on. One final thing, if you want to change the border around the outlet, you will need to swap out the part. Check the specification in design and construction guidance. It says it needs to be 500mm larger than the pipe, at a minimum, and our model can increase this up to 1 metre. Alright, to round this section off, I am going to do some surface analysis to find out where best to add gullies to the new road surface. The simplest, and I believe the most visual method, is to simply turn on slope arrows. To do this, let's change the surface style to slope, arrows and border, like so. Hey, it looks like a 1970s psychedelic kaleidoscope, but this can be very useful. You can clearly see the crossfall and longfall of the existing road here, and the direction of the arrows gives you some idea where the surface water will run. And it all looks great over here and here until we get to this section of the road, where the arrows are almost all perpendicular to the centre of the road. This means we have correct crossfall, but there's not really enough longfall, and we might end up with a big puddle. We will need now to look again at our road design to ensure we have better runoff of surface water in this area. Remember that this surface is referenced from another drawing, but we can open that drawing and change the final road surface easily if it needs it. So let's right click, open source drawing, and we can now examine the profile of the estate road. And look, over here it's pretty flat, almost no long fall. So let's change it. And I'll use the grips and shamelessly alter the design to give an obvious low point. I know I'm being a little gung-ho here, and in reality you'd spend a little more time perfecting the long fall, but for our needs I'll lower the profile and knock it over a little to the left. Ooh, and maybe too deep. Let's readjust, but you get the idea. Once I'm happy, I will rebuild the corridor. Now, whilst it's rebuilding, think about what's just happened here. We've changed the profile of the estate road alignment. Civil 3D is now rebuilding the road corridor, and this in turn will update the final ground surface that we have been using in the other drawing. You can see the result here, courtesy of my video editing software, before and after. Before and after. The after clearly shows the cutting made by the road and the effect this has on the final ground surface. Okay, let's save our design. That's important, folks. Never forget to save. Now, if we head back to the old drawing, you can see it remains unchanged. But if we closed it down and reopened it, then it would match. However, if you're working live and you've got notifications switched on, you will know that the reference has changed. It tells you. And it will ask you to resync to bring it up to date without further ado. Look, down here. Just press synchronize. And keep your eye on that problematic area. Et voila, c'est magnifique. We now have obvious long fall, and there's clearly going to be a low point around this area somewhere. Now, what has this done to our pipe network? Well, the ground levels have changed, and our pipe network followed the crown of the road. So, as you can see, it's automatically adjusted the cover level of the manholes appropriately, and this is good. However, the soffit level of the pipes have remained. In other words, it's not reapplied the rules. And remember, folks, pipe rules rule. Well, that's easy to fix. Remember, in order to apply the rules to whole sections of the run, choose any two items from the plan and click Apply Rules up here. Then pick a start and end part on the run. In this case, I'll end my rule application by selecting the structure in the field. After all, we spent a fair bit of time getting the outfall correct, and let's face it, the surface in that part of the drawing has remained largely unchanged. And bing! Done. Let's take a look at the final section though. You know, the one that we didn't apply the rules to. Well, that pipe looks pretty flat now, and on closer examination we can see there's some slope, but it isn't enough. Now, if the rules were respected and applied, it would fix the slope, but it would have also screwed the outfall height. And an easy fix here is to just declare a slope that is suitable. Remember, after all, you are in charge. So let's assume the pipes are all at the right levels. And now we're going to get a couple of gullies into the correct position. The slope arrows will certainly help at this stage, but I can see from the contours approximately where the road is, and I know roughly the area where the low point is. So we're going to use the simplest tool in the box. That's this here, the water drop. Click water drop and then select where you wish to start, and it will draw a line to the drain point. So the end points here and now here are both contenders for gullies. Let's put them in. Clicking the existing pipe network will allow us, by selecting Edit Pipe Network, to get back into design mode. This time I'm going to add a gully and a small diameter pipe. Yeah, I can snap the gully to the depression point, but I'm going to add an underground connector. To do this, select null structure. Otherwise, it'll just put another gully in. Oh. Then look at the glyph. It will split the pipe with a connection point. No manhole. Of course, you can insert a manual here if you wish, but hey, you don't need to do that. Let's do the same again, except let's feed directly into the existing manhole. Again, notice the little connection glyph. Quick tidy up, orient the gullies in the right direction of the channel line. Yeah, that type of thing. Now, to add new stuff to the profile, just select them and draw the parts in profile. Ooh, yeah, that shows a little bit of a problem. I don't like flowing backwards into that manhole. That's a bad design. Easy to fix. Once identified, just disconnect it and reconnect it where you want it. In this case, breaking the pipe again. Job done. So remember, in UKIE 2025.1, we have 3 new parts lists, 12 new rule sets, 2 new label styles, 8 new structure styles, 7 new pipe styles, 33 new manhole structures and 2 new outfall structures, as well as 2 new pipe types. Hey, have fun! Now, the other important new addition to UKIE 2025.1 is the addition of rail turnouts for Network Rail in the UK. Currently, the very latest Network Rail standard, that's NR60 Mark II, is covered. The older standards, NR56, and the previous Mark I version of NR60 will be included in future releases. What is cool about these turnouts is that geometry can be displayed as either centerline or interior rail. For planning a diverted P-way, the centerline is useful as it starts on, shockingly, the alignment that represents the middle of the track. But for checking the mathematics and for setting out purposes, the interior rail geometry will give you very important reference points, such as this crossing point here, called the interior or the inside rail intersection. This alternative geometry starts on the mainline rail that will eventually become the interior rail of the diverted alignment. Also pretty cool is the way that a turnout can bend with the main line. Now there's quite a lot going on here, and the mathematics changes to equivalate the radius depending upon the flexure of the turnout. And this is called the Swiss bending rule. On some turnouts, transitional or spiral geometry is used. This ensures that when a train transverses the turnout, the passenger experience on the train is a comfortable one. After all, you will be moving from a straight to a bend and then back to a straight again. Now, as you can see, I've labelled the transition points on this slide. And this is an important aspect of the UKIE template file in that it provides a full labelling framework for the drawn turnouts, as well as other styles and defaults. This is, of course, all fully documented, but I'd like to continue my story by showing you some of the basics of placing turnouts on rail alignments. So, back to our drawing. Let me simply hide the stuff we've been working on so it's out of the way. Now we're going to look at this area here, just over the beck and at the other side of the main Leeds to Bradford railway line. Now this has been a scrapyard for many years, but it's now being repurposed as a train care centre. Basically it's going to be where all the trains go to get washed and cleaned inside and out. Not built yet, but it's on its way, even though Esri Maps claims it's currently in situ. I know this because I was there yesterday taking photographs, and this is good news for my hometown because we are getting 6 more direct train services into London per day on the back of this. But before we crack open the champagne, let's have a look at the very basics. The best way to start creating a P-way in Civil 3D is to create a rail alignment. This is done from the Rail tab. Creation Tools starts the process. Now this is very similar to how a road alignment is made. I'll call it Test P-way and just accept the defaults. Now as you can see, there are lots of drawing and design tools here, and most Civil 3D users will already be familiar with what you can see. But I'll just create a simple straight mainline to play with the turnouts. This here represents the centre line of the track. If I want to see the outside rails, I can add them by choosing rail lines after right-clicking the P-way alignment. Notice that the defaults are matched to the UK gauge. Done! We will use these rail lines to showcase points on our turnout. Now, to add a turnout, there are a number of options, but we'll do it from the Rail tab, as the first thing we need to do is load the catalogue. NR60 Mark II is the JSON file that you need to select, and once loaded and validated, you will be able to insert turnouts from this standard. I find this easiest to do by selecting the P-way alignment first and then choosing Create Turnout from the pull down here. But there are other ways. Next, we are asked for the insertion chainage. Now, whatever insertion point you choose can either be the stock rail joint or the toe, but don't worry about that for now. Once you've chosen the chainage, by either selecting on screen or providing a fixed value, and then obviously you give the turnout a decent name, the logical thing to choose is a turnout angle, and this is the angle the diverted alignment will take when it crosses the interior rail of the main line. This drop down shows what's available. As a general rule, the shallower the angle, the faster the design speed. You will then see the specification of turnouts that match the desired turnout angle. If the model designation has a T at the end of it, then it will contain those transitional or spiral geometries that I mentioned in the PowerPoint. You can also choose at this stage over here if you want the turnout to go to the right or to the left of the main line. And if you want it to go backwards or forwards, that's here. And yep, this is where you choose what that chainage insertion point entered earlier refers to in the model. We will put it onto the stock rail joint, normally considered as the origin of the turnout. The toe, on the other hand, is where the switch mechanism starts. But hey, let's just press create and see what we get. Notice that the default geometry displayed is what I referred to as centerline geometry in the slideshow. And let's look at the other alternative, as we can, of course, toggle between the two that are available. So just go to the properties of the turnout and change the geometry option to interior rail. There you go. Now, just in case you missed it, let me show you. Centerline, interior rail. Centerline, interior rail. You might need either or at any particular time. Now, I did mention there were a whole lot of label points built into the turnouts. Add labels by right-clicking the turnout and choose Edit Turnout Labels. And of course, I can add what I want manually at the top of this dialog box, but it's an awful lot simpler and easier to import the UKIE label sets. There are 3 available. Let's add everything. Ka-ching! Sure, it looks a bit messy to start with, but it only takes a jiffy to tidy things up using the grips. And you can see as I work through each of the labels some important points such as the interior rail intersection, the heels and those two potential insertion points of stock rail joint and toe are easily positioned. If you change the geometry, then different labels are offered. And changing this turnout to show centerline geometry gives you a whole new label set. This works around a very flexible label framework. See the documentation for more information on this. And of course, the most important aspect of Civil 3D is respected. Being dynamic means you can change the whole shebang to another speed of turnout quickly and easily without losing anything. Let's face it, changing the turnout specification like this on the fly is just the icing on the cake. Now let's get back to the real world. I already have an alignment in my data shortcuts that covers the main line through the town. So let's spend a second just referencing this. The difference with this one is that the permanent way is clearly on a radius. Any turnout will therefore need to be equivalated based on its flexure using the Swiss bending rule. Now, adding a turnout here is no different to before. Just choose a chainage on the alignment. This time we'll insert it on a toe. Obviously, on tight radii on mainlines, you probably want to choose a slower speed turnout. In fact, the higher speed ones lower in this list will need a larger radius of mainline to equivalate correctly. But with this bend, let me choose a D13 turnout, which can safely and comfortably take a train at 30 miles per hour. Now, I mentioned the label framework, and you can actually choose how obscure the labels are that you wish to add. It's at the bottom of the property sheet, here, hidden in this case. I'll choose extended, and then I just need to add labels as I did previously using a label set. Again, the labels will need tidying up, and this only takes a second or two, but you can see that we have a few more labels displayed and some even appearing set away from the declared geometry. But if I add rail lines as before on the main line, and also add some rail lines on the diverted alignment, you can see how these points are valid and maybe even useful, even without that extra geometry. In this case, you can see here the very important interior crossing point of the two interior rails. Anyway, that's about it for now. I'll end on a summary slide of what's new in 2025.1, and I hope you think the time you have spent watching this video has been worthwhile. No doubt I'll be posting again next year. Thanks for your time.